Welcome to this explainer. When we talk about renewable energy, we almost always look up. We look at the sun in the sky, we look at the wind in the air. But what if the ultimate solution to our energy needs is actually right beneath our feet? Today, we are diving into a truly fascinating topic, India's very first major step into a hidden, highly reliable, and virtually untapped clean energy source. So let's just dive right into this and explore India's geothermal revolution, specifically focusing on the totally groundbreaking Puga Valley project.
Think about it for a second. Imagine generating massive amounts of electricity without burning a single lump of coal, without trucking in expensive diesel, and crucially, without worrying if the sun is shining or the wind is blowing. It brings up a huge question. Could Earth's hidden heat actually kickstart a whole new era in India's clean energy journey? Could this unseen power grant true energy independence? It almost sounds like science fiction, but as we're about to see, it is very, very real.
So here is our roadmap for today's explainer. We'll quickly cover the science of Earth's heat, then touch on the global history of this tech. From there, we'll head straight to ground zero at Puga Valley, look at the massive collaborative ecosystem making it happen, map out India's other geothermal provinces, and wrap up with what this means for a clean energy future. All right, let's kick things off with Section 1, the science of Earth's heat and exactly how this whole process works. It's actually a brilliantly simple concept. The word geothermal just breaks down into the Greek geo, meaning earth, and therm, meaning heat. Deep, deep beneath the surface, there is this enormous reservoir of heat. It's constantly being generated by the planet's original formation and the natural decay of radioactive elements. Now, in certain specific regions, this intense underground heat warms up subterranean water, creating highly pressurized hot water and steam. Engineers can just drill deep wells right into those reservoirs, bring that steam to the surface, and use it to spin turbines connected to generators. The end result? Pure, clean electricity. Moving right along to Section 2, global geothermal history. Because while this might feel brand new to India, it really isn't a new science at all. It actually goes way, way back. We're talking 1904. That is when Prince Piero Gennaro Conti first proved you could use underground steam to generate electricity over in Larderello, Italy. Just a few years later, in 1913, the world's very first commercial geothermal power plant opened in that exact same spot. So the key takeaway here is that this isn't some experimental, unproven idea. We literally have well over a century of proven global success to draw on. Fast forward to today, and geothermal is a total global powerhouse. The United States actually stands as the world's largest geothermal electricity producer right now, but right on their heels, countries like Indonesia and the Philippines are expanding incredibly fast. They are strategically tapping into their highly active volcanic landscapes to supply a massive chunk of their national electricity. We're also seeing major contributions from Turkey, New Zealand, Kenya, Mexico, and of course, the original pioneer, Italy. But if you want to see what this looks like in everyday practical life, just look at Iceland. Nearly 90% of all homes in Iceland are heated using geothermal energy. They also get a huge portion of their electricity from it. They've completely transformed their volcanic geology into the sustainable, clean energy resource that literally keeps their entire population warm. It's amazing. Which brings us perfectly to Section 3, Puga Valley Ground Zero, India's very first major project. Now, I really want you to let this number sink in for a second. 14,000 feet. Try to just picture the sheer logistical nightmare of building a complex power project at a staggering altitude of over 14,000 feet high up in the Himalayas. The air is incredibly thin, the weather is absolutely brutal, and simply dragging heavy drilling equipment up there is just a monumental task in itself. So you gotta ask, why go through all that trouble? Why Puga Valley? Well, Puga was chosen because it's basically a geological gold mine for this stuff. The region is incredibly rich in natural geothermal indicators. We're talking abundant natural hot springs, visible steam venting right out of the ground, rich sulfur deposits, and most importantly, exceptionally high underground temperatures. Scientists have studied this exact spot for decades and concluded it is hands down the absolute best opportunity for India's first geothermal power project. To actually tap into that heat, engineers had to drill 2 separate wells down to a massive depth of 1,000 meters. Think about that. That's a full kilometer straight down into the solid earth. These dual wells are designed to support India's first 1 megawatt pilot plant. Now sure, 1 megawatt might sound kind of small in capacity, but it is astronomically significant. This pilot is the ultimate test case. It's meant to prove whether geothermal electricity can be produced commercially in India. If these 1,000-meter wells do the trick, It changes the whole game.
Of course, you don't pull off high-altitude deep drilling entirely on your own. That takes us to Section 4, the collaborative ecosystem.
And before we get into the big agencies, we really have to talk about the human element here. Breakthroughs like this don't just happen overnight in a vacuum. India's geothermal program relies on literally decades of foundational research. We have to honor experts like Dr. Surjit Kumar Guha, the former Director General of the Geological Survey of India. He made these incredible foundational contributions to the geological research that completely paved the way for what is happening up in Puga right now.
Building on all that foundational work, today's pilot is just a massive, massive joint effort. You've got the ONGC Energy Centre spearheading the drilling and development, working hand-in-hand with the Ladakh Autonomous Hill Development Council in Leh. It brings together the Geological Survey of India, the Ministry of New and Renewable Energy, the Ministry of Earth Sciences, and the National Geophysical Research Institute. It is a truly multidisciplinary powerhouse team. Geologists, drilling engineers, geophysicists, and renewable energy experts all pulling in the exact same direction. Zooming out a bit, let's look at Section 5, India's geothermal provinces. Where exactly does this Ladakh pilot fit into the larger map?
You might actually be surprised to hear this, but India possesses more than 300 identified hot springs spread out across 7 major geothermal provinces. It's not just Ladakh. Beyond Puga, we have Manakaran in Himachal Pradesh, Tapawan in Uttarakhand, Bakreshwar in West Bengal, Tatapani in Chhattisgarh, and the Cambay Basin all the way over in Gujarat. This kind of potential is literally bubbling up all across the entire country.
And this is where the stakes get truly astronomical. Right now, yes, we are just starting with a 1-megawatt pilot to prove the concept. But earlier scientific studies estimate that Puga alone, just this one single location, has a theoretical potential of generating around 1,840 megawatts under favorable conditions. Obviously, the country's total economically recoverable potential is still being mapped out, but this huge glaring gap between a tiny pilot and that massive theoretical ceiling is exactly why everyone is so incredibly hyped about this project. Which leads us right into our final part, Section 6, the clean energy future. What do all these deep wells actually mean for India's broader path to energy independence? Here is the thing. Geothermal has this one ultimate superpower over basically all other renewables. Look, solar and wind are absolutely fantastic and we desperately need them, but they are intrinsically at the mercy of the weather, right? No sun, no solar. No wind power. Geothermal energy, on the other hand, provides continuous 24/7 baseload power. It serves as the constant, unwavering backbone of an electrical grid. It works just as flawlessly at 2 a.m. as it does at 2 p.m. It just keeps generating electricity, even through the absolute harshest Himalayan nights and freezing winters when solar panels might be completely buried under snow. So if this pilot succeeds, the ripple effects are literally transformative. We're talking about opening the door for massive commercial-scale plants. That means hyper-reliable power for remote villages and defense installations across Ladakh. It means drastically cutting down or even completely ending the reliance on trucking highly polluting diesel all the way up into the mountains. Plus, all that excess heat, it can be used directly for agricultural greenhouses, food processing, heating entire districts of buildings, and even boosting tourism facilities, all while fully supporting India's net zero emission goals. It's a total win-win. For decades, India has been pushing the absolute frontiers of science, from incredible space missions to pioneering green hydrogen. And now, they're looking deep underground. So I want to leave you with this final thought to ponder. Could this single 1-megawatt pilot, sitting 14,000 feet up in the freezing Himalayas, be the spark that totally redefines India's entire clean energy future? Can geothermal energy truly become the ultimate 24/7 baseload foundation of India's future energy mix? It is a truly fascinating question, and it's one we are definitely going to be watching very, very closely. Thank you so much for joining me on this explainer.